So now we will study about the heat and energy, right? So in this chapter, we will study about the concept of heat and temperature. So as we know, heat unit is energy. So heat is basically the form of energy, right? Is SI unit is joule or calorie. So and how calorie and joule is related? 1 calorie is equal to 4.186. So heat is nothing but it is the form of energy through which we are getting the energy, and unit of heat will be equal to joule, and we know 1 calorie is equal to 4.186 joule exactly. Okay, now we will study next topic that will be equal to anomalous expansion of water, as we have studied earlier, right? Anomalous expansion of water graph showing variation of volume and density of water with the temperature in the range of 0 to 10 degrees Celsius. So hopes, experiment and consequences of anomalous expansion. Next topic we will study is flow of energy and its importance. So next scope is understanding the flow of energy as linear and linking it with the law of thermodynamics. So as we know, energy is neither created nor destroyed. It is only transferred from one form to another form. Right? So no energy transfer is 100% efficient. So there is something loss when we are transferring the energy. Next topic we will study is energy source that will be renewable versus non-renewable. Right?
Sir, can you skip this box?
Okay. So yeah, right. So look here, heat and temperature, and next topic will be anomalous expansion. So we'll see the first concept of heat or heat energy. So in our common experience on rubbing our palms, right, we get heated. On passing electric current in metallic wire, the wire get heated, right? And on burning coal, we get heat. So on pumping air in the bike tube, the barrels of the pump get heated. So in these all cases, heat is produced either by doing work or by providing energy in some other form that that causes heat, right? When we are rubbing our palms, that time molecules of the palm get heated, right? And when we are transferring the volt current through the wire, electrons transferring the energy from one point to another point. And for when it is in the long consumption or for long duration, wire get heated, right? So we can say that energy transfer from one form to another form, that also causes the heat, right? Next topic is on rubbing palms or on pumping air in a bicycle tube. Heat is produced by doing work from mechanical energy, while on passing current in electric wire. Heat is obtained from the electrical energy, or on burning the coal, heat is obtained from chemical energy. Heat is also a form of energy. As we have told you that heat is the form of energy, right? So read these examples. So next point is each body is made up of molecules, right? So molecules are in random motion and each molecules exert a force of attraction, right, on the other molecules. So these molecules possess energy, and heat energy of body is the internal energy, right? So look here, total internal energy is equal to the sum of the internal kinetic energy due to molecular motion and molecular potential energy due to molecular attractive force, right? So basically, suppose this is a body, iron rod is there, so in which Fe atoms are present or Fe ions are present here. So it will transfer the energy to the next molecules. So in this way, heat energy is transferred, right, from one point to another point. That is also called total internal energy, is the sum of the energy, internal energy, right? So your next point is a hot body has more internal energy than an identical cold body, right? So hot body having more energy as compared to the cold one. So when a hot body is kept in contact with the cold body warm up and the hot body cools down, right? Due to the internal energy of cold body increases, that of the hot body decreases, right? So thus energy is transferred from the hot body to the cold body when they are placed in contact with each other. So energy which flow from hot body to the cold body is called heat energy or simply the heat, right? Because due to the difference of the energy, they are transferring the energy from one body to another body. On touching, a body appears hot to us when heat flow from hot body to the our hand, while it appears cool to us when heat flow from our body, our hand to the body. So this is the example, but main concept is when hot body is there and when it is contact with the cold
So
one,
this is a anomalous expansion, anomalous thermal expansion, right?
right? Yes, this is the normal transfer of heat energy, right? Because
Yes,
hot
the
body
thermal.
having more energy than the cold one, right? So basically there is heat transfer or temperature difference is there. So basically, as we know that it flow from higher energy to the lower one, right? That's why energy transfer from hot body to the cold one. Look at the next example. If we touch warm water, right, we feel hot because heat energy from warm water passes to our hand, right? Because molecules of the water is warm now, that's why, and our hand is cold. So basically, heat energy transfer from hot to the cold one. That's why we feel warm, right? Similarly, if we touch a cube of ice, we feel cool because heat energy from our hand passes to the cube of ice. Thus, we can define as heat is the internal energy of the molecule constituting the body, right? Heat flow from hot body to the cold one, right? So always heat transfer will be higher energy to the lower energy. So this will be higher energy, this will be cold one. So energy from higher energy to the lower energy, lower energy. Because higher energy having more kinetic energy or more energy in its ion molecule atom we can say, right? Or cold one having low energy of its atom molecule and ions, right? So write that definition
Can you scroll up?
in the box. Now next topic is our unit of heat. So unit of heat is same as that of energy because heat is the form of energy, right? So SI unit of heat is joule. So joule is written in the capital letter as a symbol. So in CGS it will be urge, right? For SI unit will be joule and for CGS it will be urge. So relation between SI and CGS will be equal to 10 raised to 7 urge. So 1 joule will be equal to 10 raised to 7 urge, right? On other unit of heat that will be equal to calorie. So it will be written in the short form of three words CAL. CAL that will be calorie and kilocalorie then it will be KCAL. So 1 kilocalorie will be equal to 1000 calorie and unit of calorie and joule are related as 1 calorie is equal to 4.186, right? So right, remember this relation joule and hours and calorie and joule, and unit is basically joule as a SI unit.
The unit of heat is same as of energy.
Now look at the next topic that is concept of temperature. So when a hot body is contact with the cold one, it is noticed that after some time, hot body become less hot and cold one become less cold, right? Due to the transfer of energy, right? Obviously, this is because of the flow of heat from hot body to the cold one, right? That's why their energy difference is created. So body which impart heat is said to be at a higher temperature than the body which receives the heat, right? So body which is hot having larger temperature, right? That's why they are following the energy. So temperature determines the direction of flow of heat. So temperature is nothing but it determines the flow of heat from where to where it is flowing. So when a body receives heat energy, the particles constituting the body starts vibrating more vigorously and temperature rises provided its physical state or dimension remain unchanged. Right? So when hot body is providing the energy to the cold one, that time its temperature increases, cold one, right? And energy it is getting more from the cold hot one, right? And due to the temperature difference, heat flow from hot body to the cold one, right? So
Yes, sir. I'll read.
read this one. Yeah. Now look at the proper definition of temperature. So temperature is the quantity which tells the thermal state of the body, right? So the degree of the hotness or coldness of the body, it determines, which determines temperature. It determines the direction of flow of heat when two body at a different temperature are placed in contact, right? So when hot body and cold body is in contact, that time it determines the temperature difference, hotness or coldness of the body, right? So we'll see the difference between heat and temperature. This is very important topic. So as we know, heat is the form of energy, right? Obtained due to the random motion of the molecules in a substance. And temperature is the quantity which determines the flow of heat on keeping the two body at different temperature in contact. Right, this is the first difference. And next difference is SI unit of heat is Joule and SI unit of temperature is Kelvin. So, so you can see that difference in the unit is there, right? Next one is amount of heat contained in body depends on the mass, temperature, and material of the body, right? But on the other hand, temperature of the body depends on the average kinetic energy of the molecules due to its random motion. So temperature gives the random motion of the particles. On the other hand, heat contains depends on the mass, temperature, and material of the body, right? Next one is heat is measured by the principle of calorimetry. So this is the main setup to measure the heat, but temperature is measured by the thermometer. So the instrument which measures the temperature is called thermometer, but on the other hand, which measures the heat, that is called calorimetry, right? So read up to 4 point, then I will explain next one. So your next point is fifth one. When two bodies having same quantity of heat may differ in their temperature, right? So quantity of heat may be same, but temperature difference will be there. When two bodies
So
having,
how is that possible?
okay, let me explain. So when two body having same quantity of heat, suppose this is having same energy, suppose 10 joule, and this is also at 10 joule, right? Energy body having same energy, but temperature difference will be there. Suppose this is lying at the 100 degrees Celsius and this is lying at the 20 degrees Celsius, right? Suppose suppose I am having 100 joule of energy to do a work, and same person having the same capacity to do the work, but temperature difference will be there, right? I am living in the hot areas and that person is living at the cold one, right? So their temperature difference is there, but energy is same for the same different people now. So that can be the possibility. And On the other hand, temperature. So two body at the same temperature may differ in the quantity of heat obtained in them. So in the similar manner, when two bodies maintaining the same temperature, like 100 degrees Celsius, but energy can be different. This will be 10 joule or this may be 100 joule, right? So at the same time, both can't be same or may be same, but difference is also there. Possible difference is also there, right?
I don't understand.
Suppose, look at the fifth one for the temperature. Suppose we are maintaining the, suppose we are taking 25 degrees Celsius for the two bodies. Suppose this is a body having heat is 10 joule or capacity to do work is 10 joule, or for the another person say B, it is having energy 100 joule. So it will do the work for 100 joule, right? So it may be difference in the energy. So you can see B is having more energy now as compared to the A, but they are at the same temperature at the same time. Now have you understood?
Yes.
Okay. So now look at the next point, sixth one. When two body are in contact, the total amount of heat is equal to the sum of the heat of the individual, right? Because when they are in contact now, so that time heat energy will be same, because then only there is no difference in the heat now, because in the A or in the B, atoms or molecules having the same energy, that's why they are in equilibrium, right? Because that time it is not transferring the heat, right? At that time it is at the equilibrium. Or look at the next point for the temperature. When two body at the different temperature are in contact, resultant temperature is the temperature between the two temperature. Okay, so resultant will be the difference between T2 minus T1. But here heat will be equal to the individual one, so it will be equal to A and B. So this is the difference. Here temperature is given by the difference of the two bodies, but it is given equal to the individual, right? So heat of A is equal to heat of B, right? So read fifth and sixth one. So now look at the next point. If there is no transfer of heat between the two bodies in contact, they are said to be at the same temperature, right? But it doesn't mean that when they have the equal amount of heat in them. In fact, temperature alone doesn't tell us the quantity of heat energy obtained in the body, right? So when two body having no transfer of heat, so they are said to be equilibrium, but at the same temperature. It doesn't mean the equal amount of heat. It means when they are at equal, heat is same. But when at the same temperature, body having heat is different to the another one. As I have told you, right? Suppose 125 degrees Celsius is there and A having 10 joule of heat and B is having 100 joule of heat. So at the same temperature, heat may be different, right? It is written here, right? And experimentally, we can find that imparting same quantity of heat energy to the different body, they get heated to the different temperature, right? Heated to the different temperature. Suppose this is body A having different heat. This is body B having different heat. They are kept at 25 degrees Celsius. This one is at 100 degrees Celsius. So they are not equal to each other at the same time. So the quantity of heat energy contained of the body depends on the mass, temperature, and material of the body. So basically, heat depends on the basically its internal structure, right? How much quantity is there of mass, and what is the temperature difference, and what is the material of the body. So this is the main things on which heat energy depends. Right. Now look at the unit of temperature. So a unit of temperature will be Kelvin for SI. Right. So it is written the short form capital letter K The most common unit of the temperature is degree Celsius, that is written as 0 degree Celsius, C, right? And for Fahrenheit, so OF. So basically three units of the temperature. First one is Kelvin, second one is degree Celsius, third one is Fahrenheit. So for SI we use basically Kelvin, right?
Yes, I know that relation.
Okay, we know the relation, right? So Kelvin and degree Celsius relation is this one. So 1 Kelvin is equal to 273 plus degree Celsius, right? And Fahrenheit relation is 9 by 5, right? So you know, right? So we'll move ahead. Look at the next topic, that is our thermal expansion. So almost all substance like solid, liquid and gas expand on heating and contract on cooling. This is the basic rule. So when we are heating the solid body, so its atom or molecule expand on heating, right? So the expansion of substance on heating is called thermal expansion of that substance. So solid has a definite shape. So when solid is heated, it expands in all directions, right? X, Y, Z direction. So its length, area, and volume also increases on heating. So increase in length is called linear expansion, and then increases in area is called superficial expansion. And when volume is increases, that time it is called cubical expansion. So liquid and gases don't have a definite shape. So they have only the cubical expansion, right? So heating, liquid expands more than the solid, and gas expands much more than the liquid. So gas expands more than liquid, and liquid expands more than the solid. So this is the order for the expansion. Right. Read once, then I will move ahead. Look at the next point. Some substance such as water from 0 degree Celsius to 4 degree Celsius, silver iodide from 80 degree Celsius to 141, and silica minus 80 degree Celsius contract on heating and expand on cooling. Right. When we heating now in this temperature difference, that time they are contracting, but on expanding, cooling on expanding. So this is the analogous behavior of water, right? So when temperature is 0 to 4 degrees Celsius, it get contract on heating, and when we are cooling it, that it will expand. So the expansion of substance on cooling in a certain range of temperature is called anomalous expansion of that substance. So we'll study about now anomalous expansion of water, how it behaves between the 0 degree Celsius to 4 degree Celsius. If we take some water at 0 degree Celsius, it start heating, right? We find that it contract instead of expanding in the temperature difference of 0 to 4 degrees Celsius. On heating, if further above 4 degrees Celsius, it expands. Similarly, if water initially at temperature of 4 degrees Celsius, it is cooled, right? At 4 degree temperature, we find that water is cooled, right? At that temperature. So it contracts till the temperature of water reaches to 4 degrees Celsius. So on further cooling, it below 4 degrees Celsius to 0 degrees Celsius, it expands. So this is the unusual expansion of the water now. So this show another behavior as compared to the thermal expansion, right? When we are increasing the temperature, that time it should expand, right? But it doesn't expand, it contract instead of expansion. And when we are decreasing the temperature from 4 degrees Celsius to 0 degrees Celsius, it should contract, but it expands, right? So this is the other difference, other behavior which is showing to the other substance, right? So it behaves differently as compared to the another substance. That is called anomalous expansion of water. So read once. Now look at the next point. The volume of water first decreases on heating from 0 to 4 degrees Celsius, right? And then increases further from 4 degrees Celsius to 10 degrees Celsius. So the volume of water is thus minimum at 4 degrees Celsius, right? For 1 gram of water, volume of 4 degrees Celsius is 1 centimeter cube. It shows the variation in the density of water with the temperature rise from 0 degree Celsius to 10 degree Celsius. So water is heated from 0 degree Celsius. Density of water first increases from 0 to 4 degree. Then it decreases from 4 to 10 degree. On the other hand, on cooling from 10 degree Celsius, the density of water first increases, then decreases, right? So you can see on the graph, because 0 to 4, it should expand, but it contract now. That's why density increases, right? Here it is written now. And volume is, as we know, density is equal to mass upon volume, right? So from 0 to 4 degrees Celsius, it is contracting. So volume is decreases. So density is increases because they are inversely proportional now, density and volume. So when volume decreases, density increases. And when volume increases, density is increases, right? Decreases. So they are inversely proportional to each other. So that this is the main point. It is written here, right?
So, water,
As we know that, as we know, density is directly proportional to mass upon volume. So when we are keeping the mass constant, so density will be inversely proportional to volume, right? So when we are decreasing the volume, that time density will increase because they are inversely proportional now. So for 0 to 4 degrees Celsius, volume is decreasing, so density will increase. This is for the 0 to 4 degrees Celsius. This is the first case.
okay, sir. So density is inversely proportional to volume.
Or you can say vice versa, right? And when we want to decrease the density, we have to increase the volume, right? So for 10 degrees Celsius up to 100 degrees Celsius, its volume will increase. That time density will get decreased. So it is written here, right, for the temperature difference. So you can see on the graph also. I will explain it to you by graph. So you can see here on the y-axis, it is given density of the water, right? Its unit is gram per centimeter cube. It is written. So density is increasing when we are moving vertically upward, right? So it is basically starting from 0, 0.9996997998991 gram, right? So this is the density for the water. And on the x-axis, we are getting the temperature. So you can see that for 0 to 4 degrees Celsius, 0 to 4 degrees Celsius, right? You can see that its volume is decreasing. So density will, so as we know, density is inversely proportional to volume. So when volume is decreasing, density is increasing. So you can see this graph is increasing, right? For 0 to 4 degrees Celsius because density is increasing, right? So you can see here its graph is increasing. So this is the increasing graph, right? And when it starts falling from 4 degrees Celsius to 10 degrees Celsius, you can see this part is another part, right? So density is decreasing here because volume is increasing because we are increasing the temperature from 0 to 10 degrees Celsius, right? Have you understood? First part is increasing and second part,
Sir, over there, density is given 0.9996. So we also write 0.9996.
you can take, this is the arbitrary value now. You don't have to remember it. This is the arbitrary value. You
So
can
what do we need to take?
take take this one only. Don't use your brain. Write this one. So for volume,
So what do I use? 0.9996, 9997, 9998.
because it is increasing by 0.001 now. So it is increases by only 0.001. So next will be 0.0002. So next will be 0.003, right? This is the density, how it is increasing when we are increasing the temperature, right? So I will show you by the whiteboard. You can see first when we are increasing the temperature from 0 to 4, so its density is increasing, right? So this is the increasing graph. And from when it is reaches to 4 degrees Celsius now, it starts decreasing. So this will fall down, right? Decreasing graph, right? Because from, as we know, 0 to 4 degrees Celsius, it contract, right? It doesn't expand. So volume get less. So when volume decreases, density increases, right?
Sir, I am asking, what do we need to write in the density column? Like over here, we write 0, 1, 2, 3, 4, and density we write 0.9996. So
Because we
we
are
write
taking
0.9.
4 only, because we are taking 4 only 0 to 1 now. So in that, in between them, you have to write this point value, right? Then only you will get difference now. We are taking
Yes, sir.
one
So
graph.
we have to use these numbers only, right?
You can, or you can write another one also.
Okay,
Like
sir.
you can also use like 0.876. Next one will be 0.898, 0 point like that. But you have to write that numbers between only 1 to 0, right? Number lines.
Yes, sir. Got it. Got it.
This is this is the arbitrary value, right?
Sir, I got it.
Now look at the Hope's experiment to demonstrate the anomalous expansion of water. So in 1805, scientist T.C. Hobbes devised a simple experiment known as Hobbes apparatus for demonstrating the analogous expansion of water. So, so we will look at the its apparatus. So look at the apparatus consists of tall metallic cylinder provided with two slides point opening point P near the top, and Q will be at the bottom fitted with the thermometer T1 and T2 respectively. So now look at the setup of this Hobbes experiment. Look here. This is the setup which is made by Hobbes, right? So you can see here, this is metallic cylinder and one thermometer is fitted here below on, and on the top another thermometer that measures the temperature T1 and bottom will measure the temperature T2, right? And it is filled with the water. So in this cylinder water is filled and this is the trough, right? And mixing freezing mixture, or this will trough mix will freeze the water, right? So this is the main setup. Read once. So part of the cylinder is surrounded by the cylindrical trough containing a freezing mixture of ice and salt. So cylinder is fitted with the pure water at room temperature, right? So temperature recorded by both the thermometer is observed at a regular interval of time. So this is the construction part. Now look at the observation. Initially both the thermometer show the same temperature because they are at keeping at the room temperature. So first the temperature recorded by the lower part T2 starts decreasing, right? And finally it becomes steady at 4 degrees Celsius. While the temperature recorded in upper part is T1 is remains almost unchanged due to the same time. While the temperature recorded by lower part is remain constant at 4 degrees Celsius. So upper will show the continuous fall in the temperature up to 0 degrees Celsius. Then it also becomes steady because temperature uh, falls temperature from 4 degrees Celsius to 0 degrees Celsius. So initially they are showing the same temperature difference, but as temperature difference is created, they are showing the different reading, right? So your next point is while the temperature recorded, lower temperature T2 remains the constant at 4 degrees Celsius. The upper thermometer T1 show a continuous fall up to 0 degrees Celsius. Then it also becomes steady. So you can see that right fall of the temperature is showing here, right? From 12 to 0 degrees Celsius. For this is the for T1 thermometer, and this is for thermometer T2. So firstly it
Yes.
decreases, then becomes steady. So you can see it becomes constant to the x-axis, parallel to the x-axis. So this show the steady or constant behavior. And and for T1 it starts decreasing from 12 to 0 degrees Celsius. It is continuously decreasing, right? So this is the graph for T1 and this is graph for T2. So make the graph. Now look at the explanation for the Hobbes experiment. Initially, water in cylinder at room temperature, right? Say 12 degrees Celsius, which is indicated by point A in the graph, right? At the freezing mixture pulls water in the center portion of the cylinder. So water contract because it is cooling by that pressure, right? So density increases, right? So in contract, as I have told you earlier, they are inversely proportional, right? So when volume decreases, density will increase, right?
Yes, sir.
Will increases here. So consequently, the cooled water sink to the bottom and warm water from the bottom rises up to take its place because cold will replace the hot one, na? So cold water will get upward. So this is the warm. So warm water will move up and cold come down, right? So thus by the convention, water of the lower part cools. So the reading of the lower thermometer T2 falls rapidly and reading of the upper one doesn't change because the thermometer of water in the upper part doesn't change quickly. So this continue till temperature of the entire water become the central portion at 4 degrees Celsius. So this is shown by the graph of A and B. Now the reading of the lower thermometer T2 become steady. On the other cooling become 4 degrees Celsius due to the anomalous expansion of the water portion now expand. So its density decreases. So hence it rises and it takes the place. Right, so this is the explanation for the Hobbes experiments or Hobbes apparatus. The next point. So at this stage, lower thermometer T2 shows the temperature of 4 degrees Celsius at which water has maximum density, while the upper part having show the temperature of 0 degrees Celsius, right? So what will be the consequences of anomalous expansion of water? So anomalous expansion of water helps in preventing the aquatic life due to the during the cold weather, right? So it is very helpful to the aquatic life. So in cold weather, when the atmospheric temperature starts falling well at below 0 degrees Celsius, water at the surface of pond initially at temperature of 4 degrees Celsius began to radiate heat to the atmosphere. So the temperature of water falling up to 4 degrees Celsius, temperature of water at the surface falls, water contact, so its density increases, right? So this is very helpful for the aquatic life. You can see on the diagram atmospheric below 4 degrees Celsius, ice at 0 degrees Celsius. So you can see upper part is having temperature 0 degrees Celsius and lower part is having 4 degrees Celsius, right? So further it remains on the surface when the temperature of the atmosphere falls to 0 degrees Celsius, water on the surface rejected heat to the atmosphere and gradually freeze into the ice. But the water well below the ice layer remains at 4 degrees Celsius. So water layer just below the ice in contact, it will be at 0 degrees Celsius. So figure 6.5 shows the formation of ice at surface of the pond. So since ice is a poor conductor of heat, so ice now prevent the flow of heat from water or pond to the atmosphere. Thus, temperature of water in contact with the ice is at 0 degrees Celsius, while the temperature of water layer ice gradually increases to 4 degrees Celsius. As a result, fish and other aquatic creature remains alive in water of the pond, though water on the surface has frozen into the ice, right? But below temperature is 4 degrees Celsius, no? That's why it get alive. So next anomalous behavior of the expansion of water is responsible for the burst of water pipeline. and the destruction of crop during the very cold night, right? Due to the anomalous behavior of water, crops get destructed. So in winter night, at the atmospheric temperature starts falling below 40 degrees Celsius. Water in the pipeline expand. It exerts large pressure on the pipe, causes them to the burst. Plant also die for the same reason as their capillary burst when the water expand below 40 degrees Celsius, right?
Yes, sir.